Let's say I have a cupboard and a refrigerator. What if I store milk, ice cream, fruits, and vegetables in the cupboard and my clothes, jewelry, and other accessories in the refrigerator? Will it work out well? Not really, isn't it? Just like we keep different things in different places in a table inside a database, each column has a specific data type to store a particular kind of data. Just give me a minute and we'll discuss this with a solid real life example. Hello learners, welcome back to Constant Learners and welcome to the third video of our SQL in-depth series. In this video, we will discuss SQL data types. Let's get started. Now, when we create a table in SQL, one very important question comes up. What kind of data are we storing in each column? Can we store numbers, text, and dates all in the same way? Can anything be stored anywhere? Not really. That is where SQL data types come into the picture. So what are SQL data types? SQL data types define the type of value that can be stored in a column. To put it simply, they tell the database what kind of data is allowed, how much space are we supposed to allocate to each column, how will the query operations behave, and so on. But why are these data types important? First, data accuracy. It prevents wrong data. Example, it will prevent entering numbers in the name column. Next is memory optimization. When you define a column in SQL, the database allocates memory, that is storage space for that data, and different data types use different amounts of memory, thus preventing the wastage of space. Third is performance. Using appropriate data types for each column can speed up query resolution, saving time and resources. And fourth is data integrity. It maintains consistency in the database. Now, there are four main types of SQL data types. The first is numeric data types. Second, character or string data types. Third is date and time data types. And fourth is Boolean data types. Let's discuss each of these in detail with the help of an example. Let's say we have an SQL query to create a student table. So we start with create table student, right? And here we have all the columns that we need inside the student table. For example, first column is student ID, second column is roll number, then we have name, gender, address, age, marks, height, date of birth, login time, and is active. In front of each of these column names, we have the data type that we need for each of these columns. For example, for student ID, we need int, that is integers. This tells the database that in the column student ID, we are only allowed to store the integers. Then, if we take the name column, we need VARCHAR for the name column. That means we are informing the database that in the name column, we can only store the textual data, right? Similarly, for marks, we are taking decimals. So, in that case, we can only store the decimal values, where there's going to be a whole number and the decimal values, right? Then, for height, we have float. For date of birth, we have date. Login time, we have date time. So this way we are informing the database what type of data do we need to store in each of the column inside the table of the database. Alright, let's discuss each of these one by one. So the first one in the numeric data type is int. Numeric data types are used to store numbers. So obviously int is also used to store whole numbers only, like age, then the student ID, count, right? For all such columns we are going to use int, because int only stores whole numbers. Alright, it can store whole numbers as big as 4 bytes, that is a 32-bit number. Beyond this, if the number is larger than this number, then we'll have to use BIGINT, right? So the second data type in the numeric data types is BIGINT. BIGINT is used to store very large integers, right? It is used when int is not enough. In most student tables, int is enough. BIGINT is used in systems with very large values like banking or large databases. Here we are using it for roll number, just for the example. Now the third data type in the numeric data type is decimal. Alright. Now decimal stores the exact decimal value. Alright. That means the whole number as well as after the decimal point. The numbers are supposed to be exact. Alright. That is why when we define the decimal data type, beyond that, like after that, we need to specify the number of spaces or the number of digits that we need for the whole number as well as for the digits after the decimal place. Like here we are taking marks decimal 3, 2. That means we are specifying 3 character spaces for the whole number and 2 character spaces for the number after the decimal point. Alright, so we can store marks with 3 digits for the whole number and 2 digits for the number after the decimal point. Alright, so that is where the decimal is used. Wherever we need to store the exact decimal values, only there we use the decimal data type. After that, the next data type in the numeric data type is float. Now float stores approximate decimal values, okay? It also stores the decimal values, but it stores approximate decimal values like height, weight, scientific data. Sometimes even it can be used for marks also, alright? Now we can use float for measurements, but never for money, because it can cause precision errors. For money, we always use the decimal data type. Alright, because otherwise it can cause problems if you're using the money for additions or subtractions for calculations. Then in that case it can cause precision errors. Alright, so for money we always use decimal, but for measurements we can use float. Now for float we don't need to specify the number of digits. Alright, because float automatically stores numbers using scientific floating point representation. That is, the decimal point can move, that is float, depending on the number. Thus the database does not need to reserve a fixed number of digits like the decimal does. The database automatically adjusts the storage. That is why here in this example, for height, we are using the float data type because it can have an approximate value. Alright. Now the next data type in SQL data types is character or string data types. It is used to store text, that is textual data. The first type in this is CHAR. Now CHAR is used when the data is of fixed length. Okay, because it always uses full space. Full space means what? The database reserves and occupies the entire fixed length, even if the actual data is smaller. See, here we denote char as char n, where n is the number of acceptable characters for each cell in a column. If I say char 5, that means I'm reserving 5 character spaces for that particular column, and the database is going to fix that space for that column, for every cell in that column. Alright, and it's always going to use that entire space. Okay, so example, if I take name char 15, so even if your name is less than 15 characters, the space is reserved fully. If I store Amit here, I'm only using 4 characters, and yet the rest 11 characters space is reserved and stays unused. So in this example, we are using char data type for gender, because we know that gender is either going to be M or F, which is a single character. So it is a fixed length data. So if we need to store a fixed length textual data like enrollment number, then char is a perfect fit. Otherwise, it is advisable to use varchar. Alright. So the next data type in string data types is varchar. Now, varchar is used where the data is of variable length. Alright. Varchar also we denote it as varchar n. So n here specifies the maximum length of memory reserved for each cell. So the data that we are storing could be less than n characters. Alright. So it uses only the required space. Alright. And hence that prevents unnecessary reservation for empty space, because n here is giving the maximum space that can be used for that particular cell. But that does not mean that that is the entire space that is being reserved. The only space that is being used is the amount of data that we are storing in that cell. So varchar is a character or string data type, which means it can store letters, that is alphabets. But along with that, it can also store numbers from 0 to 9. It can store special characters like @ hashtag, hyphen and slash, and it can also store the spaces. Alright. So it is the best data type to be used for names, for addresses. Alright. Because in address we have pin code, we have house numbers, street numbers. So for that, varchar is the perfect data type. But even though numbers are stored here, they are stored as text, not as numeric values. That means we cannot perform any mathematical operations here. Alright. Now in this example, we are using name varchar 50. That means we are reserving maximum space of 50 characters for each cell in the name column. Similarly, we have address varchar 255. That means we are reserving maximum space of 255 characters for each cell in the address column. But that does not mean that the database is reserving the entire 255 characters for that particular cell. It will only reserve the characters that are being used to store the address. The rest will stay empty and can be used in other places. Next data type here in the SQL data types is date and time data types. And the first one here is date. Date is used to store date. Alright, like date of birth. And SQL follows a specific format, a standard date format, which is year, month and date. It cannot be modified. In this example also, we are using the date data type for storing the date of birth. Alright. Next we have time data type. Time is used to store time. Alright. Next is the date time or timestamp data type, which is used to store both date as well as time. Alright. It stores, in this example, we are using it to store the login time, which stores both date as well as time. And finally, the last data type in SQL data types is Boolean data type, which is used to store two values, that is true or false, 1 or 0. Here in this example, we are using it for is active, to store is active, that is whether the student is present or not. Alright. But it is not universal, because Boolean is not supported the same way in all the databases. We need to remember that SQL is standard, but data types vary across different databases. So we need to work accordingly. Alright. So selecting appropriate data types for each column in every table is a fundamental step in designing an efficient database. If done correctly, it significantly reduces complexity and effort later. Now I want you to quickly answer these 3 questions in the comments below. First one is, which data type would you choose to store a person's name, char or varchar, and why? Pause the video and please answer the question. Next question is, why should we use decimal instead of float for storing salary? Again, pause the video and answer the question. And the third one is, what is the main difference between int and BIGINT? So in this video, we learned that choosing the right data type is the first step towards designing an efficient and reliable database. If you like this video, don't forget to give it a thumbs up, subscribe to Constant Learners, and thank you so much for watching.